And when I say the manufacturing processes, this is as common as brewing the beer that we drink at the end of the day. It's sterilizing vessels to be able to put medicine in. It's cleaning, it's pharmaceuticals, it's cosmetics, it's chemicals, it's everything that we use on the day to day. Some way, somehow, steam touches that.
Hi, everyone. Welcome to the Climate Confident Podcast. My name is Tom Raftery, and with me on the show today, I have my special guest, Addison. Addison, welcome to the podcast. Would you like to introduce yourself?
Great to be on here. I appreciate you doing a recording with me so I can come on, talk a bit about steam, boilers, and their role in climate. A little bit about myself. I come to this podcast by the long way of starting as a farm boy in the Midwest of the United States. I was surrounded by agriculture and the change around me as new forms of fuel came along, ethanol, other things like that, that got me interested in climate technology because I also started to see how climate was impacting agriculture. That brought me to university where I started to work on these things at the University of Iowa. But then I went where I really started to supercharge my work in energy and climate was when I went to grad school at MIT. I went out east as a naive Midwesterner and found my way into becoming a mechanical engineer, working on combustion, how we could make it more efficient. But as my career progressed, I found that I'm now working on bringing a boiler to market that gets rid of combustion entirely. And I think that that's kind of the path that we're going down in terms of electrification for the long haul, for being able to address industrial emissions on each of its forms. So looking forward to talking about that. That's just a little bit about me.
Okay, superb. And let's start with the elephant in the boiler room. What problem do you see in how industry handles the heat that's made today? I mean, obviously you think it needs to change somehow. Why?
So I think it's worth going back because the industrial steam boiler is as old as industry itself. In 1867, Babcock and Wilcox patented and productized the combustion boiler. They moved it from being a stick-built, brick-by-brick project in a small manufacturing facilities in what we would call industry at the time, textile mills, grain mills, other kinds of things. And then they brought it to become a factory-built product. And really it became the catalyst for the Industrial Revolution. If you look at kind of charts of growth of industry, you see this inflection point at the end of the 1860s. And since then, steam has been the most important working fluid. And when I say working fluid, that's a technical term. It really means a transfer medium for heat in manufacturing. And it drove the Industrial Revolution, but today it's still half of all heat delivered in industry is delivered by steam. It's all delivered by these products that if you look at them, and if you were to bring an engineer who worked for Babcock and Wilcox in that time, they wouldn't be floored by what they see in the boiler room today. They would instantly recognize what they see: a shell and tube, heat exchangers with fire on one side, steam on the other, water boiling, and then steam going throughout the facility to be able to deliver heat. Now, it's important that we use steam. Steam, the reason we use it is it's a really good heat transfer media. The energy and the power density in the phase change from gas to liquid, liquid to gas, is tremendously powerful. We can pack a lot of heat transfer into a very small surface area, meaning that we can actually do the intense manufacturing processes that we do today. And when I say the manufacturing processes, this is as common as brewing the beer that we drink at the end of the day. It's sterilizing vessels to be able to put medicine in. It's cleaning, it's pharmaceuticals, it's cosmetics, it's chemicals, it's everything that we use on the day to day. Some way, somehow, steam touches that. And so I saw that as a tremendously powerful technology that we're talking about that has been ripe for innovation because, like I said, it's the same way we've been doing this for 160 plus years.
Mm-hmm.
What if we could go and electrify that and clean that up? That could be a tremendous opportunity in addressing climate change and other emissions associated with on-site combustion.
Okay. question for you coming from complete naivety on my part. My son, my older son, drinks tea. And he makes tea by boiling it in a kettle. And that heats water using an electric element, which is resistive heating. So you run your current through it, it heats up through resistance, that boils the water, out comes steam. Now, it's not steam that would drive a turbine or anything like that, it's just a byproduct of the boiling of the water. If we are going to go to heating water, not using combustion, but using energy, you've not gone the path of resistance heat, you've gone a different way. Why?
So this is a great illustrating technology because I use this all the time when I describe what we are doing. So what you're referring to, an electric tea kettle, plug it into the wall, and you have a resistive element in there that is doing exactly like you said. The electricity is boiling water. You're essentially taking 1 unit of electricity in, you're getting 1 unit of heat in the water. And then when it's boiling, what's really happening is you're generating 1 unit of steam leaving that. Now, in your son's tea kettle, it is not exactly useful steam. It's at ambient pressure, which means that it's at about 100 Celsius or 212 Fahrenheit for each of our preferred unit listeners. And that's great, but it is not what we're using in industry. That's generally higher temperatures, higher pressures. But let's start with this as an example. A resistive element or a tea kettle like that, or in industry what we call an e-boiler or an electrode boiler, a resistive boiler, is built on the same principle but at industrial scale. So this is the fastest growing subsegment in boiler market today, growing at about 15 to 20% year over year. People are buying resistive boilers for applications in industry because they are either looking to electrify to get away from gas where it might not be available. This is an acute issue in Europe, particularly since the loss of pipeline gas from Russia. Or there are very specific site and corporate climate goals they're trying to achieve, and electrification is the most expedient way to do it. So these resistive boilers are truly the one off-the-shelf product to do this today. Now, what we're doing, and at my company, AtmosZero, what we are focusing on is doing electrification of steam in a much higher efficiency way. So we are packaging a heat pump technology instead of a resistive element to be able to generate steam. And we do this with a heat pump that is capable of reducing that electricity consumption to generate that steam by at least half. So for every 1 unit of electricity in, you get 2 units of steam out. And that's the core part of bridging the economics to be directly competitive with combustion and make it cost effective to be able to scale out electrification. Because what your son's using in your house, that's great for the personal consumer. He uses that. Maybe he's a true tea addict and he's using it 4 or 5 times a day. Oh, he is. And so, that is, you can imagine that being used in total of about 20 to 30 minutes per day. Now, if you're running that thing 24/7 at a megawatt scale in a facility and industry, that is incredibly expensive, and people are really incentivized to find a more efficient way. So that's the problem we're working to solve.
Okay. And why has industrial heat, especially steam, been so often overlooked in climate discussions, even though, as you say, it's such a massive energy user?
Well, the first order thing is the combustion boiler works. The combustion boiler's cheap. And we as a society over the past 100 years have invested heavily in building out natural gas infrastructure to every industrial site, commercial site, and residential site, particularly here in North America, where I am, but also it's not dissimilar in much of Western Europe. So the switching costs have been high, both in terms of moving away from the infrastructure that's been built and is available to us, but then also the increase in OpEx and CapEx of going after the resistive elements, essentially. However, people are choosing that even though it's costing more. Now, why haven't we seen a scaling out of industrial heat pumps in general is a more complex question. But the 2 main drivers there are, number one, we've seen continued innovation in heat pumps for residential application that has improved the technology available to us. It would have been rare to find heat pumps in homes delivering heat even 20, 30 years ago. And now they're the fastest growing segment in the furnace market is replacing combustion. And that innovation can be leveraged. And that's what we're doing to be able to go, not just stopping at that 40 Celsius necessary to drive and keep a building at 20 to 25 Celsius, but going all the way up and delivering heat above 160, 170 Celsius to be able to deliver pressurized steam for industry at 150 and above. That's the core innovations that have been leveraged from the past couple of decades that are now possible to deliver industrial heat pumps. The other challenge that we have seen in that market is all industrial heat pump companies up until this point have really had an obsession with bespoke projects on site. The challenge we've seen so far is people will focus on going into an industrial facility, identifying every source of waste heat, which I'm sure you've heard people talk about the value of waste heat before. I have a little bit of a different take on this, that waste heat has been a distraction from scaling, and we can talk more about that. But by focusing on waste heat, what you start to find is every manufacturing facility, every brewery, every bakery, every laundry is different in layout, in temperatures of waste heat available, in types of reactors they're using. So you don't have a one-size-fits-all industrial heat pump solution that is able to capture that heat and upgrade it. You're actually running into very expensive one-off, CapEx-intensive projects. So we at AtmosZero have decided to take the different bend, is look at what's been successful both in traditional combustion boilers and in building heat pumps, which was standardization and factory built around one spec. So we ignore that waste heat. Essentially, we build a heat pump that is an industrial heat pump, waste heat not required, that can drop in a very standardized way and avoid the one-off costs that have made it so industrial heat pump boilers have not been scalable up until this point. So there's some nuance into what kind of innovation we've done to do that. But what we really think, in maybe the most pithy way to put it, is we are focusing on making a decarbonization product, not a decarbonization project.
And what are there limitations to the product in terms of latitudes it can be used at, temperature ranges it can be used at? Because I've heard it said about residential heat pumps, falsely generally, but that they don't work in hot or cold climates. So are there any such limitations with the heat pump you've come up with?
Yeah, Tom, that's a really important insight and question. And what we see is actually the economics are quite different in the industrial setting than they are in the residential setting. So if you look at a residential heat pump, that is delivering heat from late fall through mid-spring. It's working to be able to deliver heat only from the coldest source temperatures outside during the year. However, in industry, steam's used 24/7, 365. In the hottest days of the summer, there's just as much steam needed as there is in the coldest days. So the performance and economics of a residential unit for delivering heat are heavily weighted to the coldest days, the lowest efficiency possible. However, once you look at the full annual cycle, our systems and heat pumps sourcing from ambient air or industrial water are much more constant in their performance and are able to benefit from the hotter days in the summer to have higher efficiency, and it makes up for the more challenging economics of the winter. Now, that's not to say that with what we do at AtmosZero, which is an air-sourced unit, if it's negative 20 Celsius, we're operating at a lower efficiency to deliver that same amount of steam than if it's 20 Celsius out. But that integral over the year makes up for those operational differences. And the core concern in industry is making sure you're able to deliver the same amount of steam every day. And that's what we engineer to, because it's a critical utility and you need to keep steam flowing to keep product flowing.
Sure, of course. And industrial heat is often labeled as hard to abate. Did that reputation make this more appealing to you or more daunting?
This actually brings me back to my first interest in this space. In 2020, COVID came along and everyone picked up their habits, right? I was baking sourdough and I was grinding my axe against this idea that industry is hard to decarbonize. Because at the time, the framing, and I think this framing still exists in industrial decarbonization, is that we've got steel. Damn, that's hard. We got cement. Wow, that's daunting. We've got refineries. We've got chemical facilities. We've got this, that, and this. And there was a very vertical framing around every single material, every single chemical, everything we use today had to be reinvented to be able to actually decarbonize that. That's very challenging because what if we're imagining the hundreds of tons of nickel that is produced per year? Do we really want to invest all of the R&D and the new manufacturing capacity to make something that's such a small sliver of industry but would require just as much R&D work? Now, in 2020, I started to ask this question and I looked at it and say, well, instead of looking vertically around each material, if you start to look at horizontally, what's common among each manufacturing process? And you start to see that heat itself is 3/4 of industrial emissions. And then if you start to look at, well, how is heat delivered? It's generally delivered by some pretty common standard products: furnaces, immersive heaters, not dissimilar to the tea kettle, and then the steam boiler, the combustion boiler itself. And in particular, the combustion boiler is already productized and standardized about very real standardized products that have existed for a long time. So if we could focus on something that is actually as scalable and it can be dropped in as easily as the combustion boiler is today, that's where I really saw something that breaks that paradigm. It's labeled hard to decarbonize, hard to abate today, but I would argue that it's not.
Okay, and you said it's drop in. What does that actually mean for facility managers or engineers on the ground if they take delivery of one of your heat pumps?
So when I talk about drop-in, I think about how are they installing a combustion boiler today? Most manufacturing facilities, I think it's important to point out, it's not like in a cartoon or something where you go into the boiler room and there's one big boiler. It's a little eerie, you have the fire blowing out of it, you know, you kind of think of like Tom and Jerry or something running through a basement. What's really going on is you have 3 or 4 of the same boiler in parallel. Each of them are side by side. They're all connected to the same, what's called a header, where all the steam gets collected into one common pipeline, and then it all gets distributed into the manufacturing facility. So if they're operating downstream in manufacturing, sometimes you have one reactor going, sometimes you have 2, sometimes you have the whole facility is humming, call it 2 p.m. in the afternoon, and then all the boilers have been turned on to be able to maximally deliver steam. But you have that ability to modulate up and down the number of boilers that you're running. And so drop-in to me means a solution that can directly integrate in parallel and potentially replace one or all of those in the same way. So it's about having a standardized product that you could swap it out for 2 of the 4 boilers, have 2 of them in there, and then 2 new AtmosZero boilers. And that allows for this kind of drop-in integration that does not require a complete facility overhaul. It allows a manufacturer to replace one boiler if it's hit its end of life, or if they want to proactively start to remove boilers and progress with electrification and decarbonization on site. It's an option to be able to do it in a plug-and-play way. Now, what does it mean to install something like an AtmosZero heat pump? So we wanted to focus on making it as easy as what they're doing today, which is integrating a resistive boiler. Today, some people are replacing one of their combustion boilers with the large industrial tea kettle. And so they'll do that in parallel in the same way. And what that really means is you need to be able to connect to power. You need to be able to have the boiler water source come in. And generally, there's one common source of treated boiler water that's being used for delivery to all the boilers. And then you need to be able to route your steam into that same header. That's it. You need electricity, you need a source of water, and you need to be able to deliver it to the same place as the rest of the steam. And so that's what we wanted to bring to heat pumps. By ignoring waste heat, we can integrate as easily as one of these other electrified solutions. The challenge we've seen with industrial heat pump solutions that capture waste heat is you do need those three connections, but then you also need access to waste heat from somewhere in your facility. And oftentimes that means building an additional heat exchanger to capture heat off of one of the manufacturing lines in the manufacturing floor. It's highly invasive. You have to run a refrigerant line or some sort of a collection through the facility. It might mean shutdown and increasing complexity of circular dependencies within the facility itself that is made for ongoing challenges in integration complexity. So we wanted to avoid that. And the other important piece about that is all of those things are bespoke. They're different, whatever facility you run into. And that's where things are not scalable and you have very high, what's known as non-recoverable engineering costs, NRE, that you can't take any of the learnings from one site and then apply it down the street in the next facility.
So you've gone from concept, obviously, to deployment. I guess first question is, what markets are you serving geographically? Because you are based in the US, are you just serving North America for now, or are you gone beyond that? And then are plans to expand around licensing the technology, or are you going to start building more manufacturing facilities, or what does that look like?
Great questions. And then the first thing I want to talk about is, yes, we've gone from concept to a deployment in the field. And I don't want to overlook that and talk about the future right away because that's hard. One of the core challenges that we're seeing in scaling climate technologies and being able to bring technology to the market is we're bringing novel innovation into a world of incumbents. And so it's a tremendous challenge for startups to do. Many cannot do that. And so first off, I'm just tremendously proud of our team of being able to go from that 0 to 1. We have an operating boiler in the field operating next to combustion boilers at a brewery here in Colorado, which is a very nice first deployment. I don't
Fantastic.
Also, it's, there was a good carrot, a good light at the end of the tunnel. We're going to be operating, we're going to help New Belgium Brewery brew beer. And that's been great. Also to find out that our steam has not changed the flavor of the beer in any way, shape, or form, though I do make sure to get over there and confirm that as a very important customer experience metric. But you're right. So that's where are we going from here? As a startup introducing a new technology is you need to celebrate your wins, but you got to quickly sprint to the next thing because we are both racing against financial expectations and also, our desire to make impact on a global climate scale. So what we're doing is scaling through markets that are driving demand for what we're doing. Number one, we're in a brewery. That's food and beverage. A brewery looks very similar to a tomato processing facility or anything where you have cooking, sterilization, canning. You need to be able to use steam to keep things clean. You need to be able to use steam to drive the cooking or the boiling process in the case of beer. So food and beverage is a big market, and that is active and interesting here in the US, in Canada, kind of broadly across North America, and also in Western Europe. We see and we're active in that market. Also, other sectors that we're very engaged in, which have a strong demand and a high utilization of steam, are in specialty chemicals. Think cosmetics, pharmaceuticals, these kinds of things, personal care products. And then the built environment. Older buildings, I'm sure we've all spent some time in one, will have an old clinky radiator. Well, if you're in very large buildings, think large skyscrapers or big apartment complexes in New York or London, there's legacy steam in a lot of these places that need a drop-in replacement to help to decarbonize the built environment. These are places where steam is still very common. Then district applications too. University campuses, research campuses, business campuses where you have some application think of sterilization of biological labs or being able to just do building heating. These are places where steam has still been very valuable. These are all places that we're focused and we're scaling through them. So we have a manufacturing facility here in Colorado. We are focused on being the building as an OEM manufacturer of these boilers and scaling them globally. Today, we're delivered here to Colorado. Next year, we are actively planning to deliver to Canada, to other places in the US, and our first deployment to Europe. We can't name the customer yet, but a major global manufacturer in Europe who is actively looking to replace their combustion boilers in their global manufacturing footprint with something that is standardized and scalable. So exactly the type of technology we're trying to scale and validating with that kind of a company we're excited about. They're in the chemicals sector.
Nice. Very nice. Very nice. And what does success look like in the short term, in terms of units installed, emissions saved, policies passed, any of these kind of things?
Success in the near term for us looks like two things. Number one, happy customers. As we start to deploy, and we think about scaling prudently. So we deployed 1 unit this year. We're going to be deploying a handful next year, and then in 27 and beyond, we really start to ramp up into the tens and hundreds of units per year. It's all about being able to scale prudently and working with key customers who have a vision to be able to scale this out, not just in one facility, but multiple. And so we're taking the same framework of what combustion boilers look like. What's important for customers is, yes, efficiency is important. Yes, lowest landed capital is important. But also what's important is one standardized boiler for all of their facilities, to have one common product that has the same replacement parts, the same service agreements, something where you don't walk into a different facility and you've worked with a company and you had a one-off project and oops, that company no longer exists. How do we maintain this thing? So we're focused on those core pieces of value that have existed in industrial equipment for a long time. I like to think we've reinvented the boiler. We don't want to reinvent the boiler market. And so for us, it's how do we start to become just boring? Like we just happen to become the go-to electrified boiler solution. And there's nothing particularly sexy or notable about us. We are just cranking out boilers and delivering steam for customers and allowing them to immediately eliminate those scope 1 emissions, move it to their managed scope 2 electrification so they can then use their procurement to help drive the demand for more clean electricity on the grid to be able to continue to drive down emissions.
And I'm glad you mentioned Europe. How is regulation shaping demand for this kind of solution, especially with the Fit for 55 in Europe? And also, the energy prices in Europe are still quite volatile. How does that affect the business case for electrifying heat?
There's a very interesting market dynamic in Europe, right? I mean, we all know that in 2022, when Russia invaded Ukraine and then there was the subsequent sabotage of Nord Stream, that the energy markets in Europe completely shifted. We're in a new paradigm going forward where the price floor for gas increased significantly and is much more closely tied to global LNG prices than pipeline. And that is fundamentally different than here in North America, where there's a robust national pipeline from US supply, which makes it very cheap here. In Europe, that's different. And so that has changed the outlook for manufacturers and steam utilization and all heat in general in Europe, that electrification not only can be economically beneficial just from a clear kind of like bottom line calculus, but also it is a diversification of supply. To be able to move away from reliance on gas means that you are able to control your own destiny a little bit better as a manufacturer, and being able to ultimately have some sort of fuel flexibility is helpful for keeping manufacturing up. That's one core thing that has changed and really is a core driver for electrification. The other thing is the climate goals. So there's been much more robust policy and policy durability in EU around climate and having price signals for emissions, particularly in the industrial sector, where the ETS and the introduction of CBAM and other sorts of border adjusted mechanisms to support manufacturers really allows for long-term investment on a capital basis into something that is more cutting edge, something that allows them to be a first mover and achieve electrification and emissions reduction, but knowing that the price and market supports, the policy supports are there, has been really important for the market that is different than the US. Now, we see it a little close to home too, and I want to acknowledge that in North America, the place that looks the most like Europe right now is Canada. There is a little bit of policy shift there, but there has been more policy durability and a recognition of the progress forward is through kind of robust price signals and being able to support manufacturers. And so we see that as something closer to home, but that's why we see tremendous demand pulling us into Europe as well.
Makes sense. Makes sense. Is this a case of if we build it, they will come, or do we need more aggressive policy nudges, do you think?
You know, that's interesting, right? I think there are, if you think about customer segmentation, there are customers who are champing at the bit for this solution. If we build it, they will come, or if they demand it, we will ship, also as a way that we're ready to go for those customers right now. But that's not everyone. You know, there's a complex calculus that goes into industrial equipment purchase because you're talking about a 20-year asset in a manufacturing facility and laser focused on rates of return, payback periods against the baseline technology. It's highly driven site by site by what are they paying for gas today? What are they paying for electricity? What does the future look like? What is the policy risk that any individual company is willing to take on? So there's a complex set of drivers here, but we do know from the market and where we engage and the customers we directly engage with, there's a large demand for what we're doing that as we start to scale up production, we see support for what we're going to produce through the end of 2030 easily as we continue to scale into the thousands of units a year. Now, if we're talking about driving the full electrification of steam worldwide and being able to say we've eliminated that 2.25 gigatons per year that steam is, that is a journey that's going to take the next 3 decades. You know, we're talking about turning over 20, 30-year assets, some that are being installed today, combustion boilers that are installed today are going to last for 20 years, 20 plus years. And that's why I really think about we've reinvented the boiler. We don't want to reinvent the boiler market. In the long haul, we just want to be in that catalog of options. And as policy evolves, as adoption curves change, we are the default solution. And that's where policy can be used for 2 things. Number one, as an accelerant for today to be able to drive early adopters faster. That just in general helps to create a shift among capital projects engineers, among plant managers, the people who interact with the equipment day to day, to see it operating at a competitor site or a colleague site shifts understanding of risk tolerance. While there are sustainability officers everywhere who want these things, it's really the plant managers that still need to hit their bottom lines no matter what tech's in there. They're much more conservative. So that's one important thing that policy can do is get more into the field faster. And that's just a rate of, make it more attractive to do it sooner. And that's often just financially driven. The other thing is the long haul. And that comes exactly as what we noted about before in the European market is long-term carbon price signals. However, the policy mechanism, whether it be a tax, whether it be cap and trade, whether it be border adjusted mechanisms, whether it be more of an incentive and direct incentive programs like the US was attempting, some sort of de facto price signals is what's needed for the completion. However, the market itself is large for electrification and enough for us to scale and really become a successful financially driven company. And that's what we're focused on today.
Okay. And do you think industrial heat will follow a similar arc to solar or electric vehicles, with steep cost drops, mainstream adoption, or is this totally different? I mean, we saw in solar and EVs and storage as well, particularly the learning curve kicking in, a lot of that being kicked off by incentives from governments. And you mentioned as well that boilers put into place today will last 20 years. But we've also seen as well in the EV space, some countries are rolling out scrappage schemes to encourage people to get rid of older cars. Do you see something like that being brought into this space as well?
So there's a couple of interesting threads there that I agree with you on, which is learning curves are everything. And learning curves only happen for technologies that are standardized into one product. You get to volume, you're able to drive your learning curves with one standard product, and that's not possible when you're doing a bespoke project. So that's why we went for productization for that same reason, which is solar, building heat pumps, commercial heat pumps, things that are standard products, you can drive down learning curves. And that's on a cost basis. Now, the demand side is different, and I think that's where we're going to be distinct from rooftop solar or EVs, because those are consumer products. There's a cool factor, or there was for some time a cool factor with EVs. We're seeing a little different dynamic now, but that demand had a different thing. What we interact with are engineers. The people who buy boilers are not Tom and Addison. They are senior project and capital engineer for DuPont Northeast US, or people who have a career of understanding the dynamics of industrial equipment. They have a very strong understanding of risk management, of what it really means to have downtime in a facility, of what it means for the P&L in their corporate governance, and what kind of therefore incentive structures they have in front of them, which are not, hey, that's a cool tech, is how does it operate? How many hours has this operated in a different customer site? Have they operated for 10,000, 100,000? Is this the default solution that 3M uses? There's much more of a analytical and rigorous decision making that sexiness doesn't play in. So boilers are going to take a different demand dynamic that's going to be heavily influenced by pricing, and particularly through policy for carbon, but also for the fundamentals of the economics of what is the electricity cost, what is the gas cost, and is this product durable? Is this product going to perform in the same way that our combustion boilers always have, because our facility has been built around that. So it's smarter customers in many ways because they are highly analytical, but it means that we can't just paint this thing red and call it a hot rod, even though it is orange. We need to focus on the core performance metrics and focus on what really matters from corporate industrial manufacturing KPIs.
Okay. Why orange?
Well, it popped. Our company color scheme is red, white, and blue. I took a pretty strong American approach to this. I have a little bit of a view that the industrial heat pump industry has been this nascent European industry because of kind of this European predilection for theoretical optimization in industrial application. We wanted to take that American productized approach. So I kind of had that as a fun way to play with this. And that's why I'm so excited about the European market for us, because it's a little bit of an American swagger, but in a fun way. We have a European team with us, a German guy who gives me a hard time all the time about this approach. But, I think that a little bit of reimagining what we're trying to do in industrial heat takes this kind of transatlantic collaboration where there's the right market in Europe, there is an appetite, there is a strategic vision, and we're excited to be part of that as this taking a little bit of this American productized approach to what we're trying to do there.
If you had a magic wand and you could magically change one policy, one standard, or mindset to speed things up, what would it be?
It really gets into the weeds a little bit, but I think it's a beautiful history. The boiler itself, and the reason that Babcock and Wilcox productization was so important, was it was not just about driving down cost, it was improving safety. So by factory building, you had standards. And actually, the American Society of Mechanical Engineers, ASME, which is now really kind of an international organization, was created to build boiler standards because there were too many boilers blowing up and killing people in the 1800s. So by standardizing, we were able to shift the paradigm towards safety, but there continues to be a legacy set of standards which are very important for boilers, particularly the high pressure side where the steam is. But it's not necessarily the same if you're replacing the combustor, where if you have flames, you're talking about getting up to 2000 Celsius, with a heat pump where our highest temperatures are in the low 200 Celsius. There are some regulations of what a boiler is that are different now as you're deploying heat pumps. And I think that there's opportunity to rethink boiler regulations in the age of electrification, where inherently we are building and delivering a more safe system with lower pressures and lower risks of high pressure failures that were traditional combustion boilers, when you would get to very high pressures, if you overpressurized at high temperatures, could explode. So these things are, when you get into the weeds of industrial equipment and what you're designing to build, I think we have an opportunity, not at the carbon pricing level, but at the standards and performance metrics of the individual piece of industrial equipment, an opportunity to rethink what a boiler is and what kind of regulations are around it moving forward. Because we continue to drive towards overall electrical and energy efficiency and carbon emissions reductions, but also we are bringing a more safe product to market, which is exciting too.
Nice. Yeah, of course. A left field question for you, Addison. If you could have any person or character, alive or dead, real or fictional, as a champion for industrial decarbonisation, who would it be and why?
In so many ways, the stories around the early development of electricity, when you look at Tesla and you look at the early days of GE, while it's not an individual, you see that race of AC versus DC. I think we're seeing that again in industrial heat right now. There's all these new entries into this. There's other heat pump companies that are trying to take different angles. There's thermal storage companies. And I think there is a little bit of an opportunity for the creation of new, bigger than life characters as we try to race to solve this. I don't think I'm one of them. I think I'm just a simple Boilermaker, but I have enjoyed seeing at least the caricature at the top of electric vehicles was, Elon Musk for some time. I could see this being these core rethinking of decarbonization deserves a few more characters, I think, and that could be fun. An individual from history, I don't know. It's hard to tell. Something that could be really interesting is, somebody like a Captain Ahab or something like that. And, steams are a white whale and we find ourselves out into the far in the abyss. That said, I like to think of Moby Dick as like the first great story about the energy transition. And so, that's just a fun historical record itself.
Nice. Nice. Okay, great. We're coming towards the end of the podcast now, Addison. Is there any question that I didn't ask that you wish I did, or any aspect of this we haven't covered off that you think it's important for people to think about?
We talked about it at the top, but I like to hammer points home. And I think that's one of those things that I've learned in communication along the way, which is steam continues to be ubiquitous. We think about the Industrial Revolution. We think about steam boilers. We think about radiators in our grandma's house from the 70s and the 80s, and all these things are disappearing. But while many of those things are no longer as consumer or individual facing, it is still such an important medium that we need to address, because it is all of industry has been designed and built around it because of its properties. And it's something that, while it's hidden, the boiler room is in the basement, it's in the back of the facility, no one sees it when they go on the brewery tour. It is incredibly important, and I'm glad that I was able to come and talk about it today.
Nice. Lovely. Great. Addison, if people would like to know more about yourself or any of the things we discussed in the podcast today, where would you have me direct them?
People should go to AtmosZero.energy.
Okay, fantastic. Addison, that's been really interesting. Thanks a million for coming on the podcast today.
This was great, Tom. It was a pleasure, was, I would say, equally mine.
Great. I love it. Thanks.